This question gives us an expression, and we know this has to be a factor of that expression. All four of the constants have to be positive, and we need to find the greatest possible value of b, which is that constant. And just so we're on the same page here, anytime you see factored form stuff like this, assume that the coefficient and constants are integers, because it has to be possible to solve with algebra, and you can't be a decimal, or else it wouldn't be possible. So assume these are integers. I went ahead and wrote the equation and its factored form. And by the way, this is the exact same thing as this. It's like standard form for quadratic and the factored form. Right, so we did the exact same thing. Here, this is what was already given in the question, and I put this as pretty much like just a dummy factor, because we need two factors here. And I just put a and c as dummy constants, just because a and c wasn't already taken. So I put that there. And then we want to make this side the same thing as this side, because our goal is to maximize b, right? That's what it says in the question. When you find the greatest possible value of b, I think the easiest way to do that is to just get b equals some kind of equation. Then we can just like get the equation and see what the highest value for b is. So to do that, let's first try to get b as an equation, like b equals something. And we should do it in terms of p and r. Right, so let's just first FOIL all this out. So we can do p times a plus p times c plus r times a plus r times c, right, foiling, and then we can combine like terms and we get something like this, right? And you notice since this equation has to equal this equation, we can see that 34 must equal PA, and B must equal this, and 60 must equal that, because they're in the exact same spots, right? So let's write that in equation form. Once you do that, we have an equation for B now. The problem is there's 4 different constants. It's going to be really complex, and we're plugging a bunch of different values. I think the easiest way is just to get in terms of P and R. We can do that, right? Because if we rearrange this equation, we divide the P over, and then we divide the P so that it cancels out. We can substitute that in for A. And then it's going to be in terms of P now. Same thing for this. We can divide the R over and substitute that in for C, and then it's going to be in terms of R. So then we get the equation of B equals P and R. So let's do that. Now that we have the equation of B in terms of P and R, we can just plug in all the possible values of P and R and just find the highest value for B that it returns. The problem is P and R have to be factors of 34 and 60, right? R has to be a factor of 60, and P has to be a factor of 34. And they have to be integers too, because it's implied in the question, like I explained before. How do we do that? You could do that really easily. I'm sure a lot of you can do that in your sleep, and you can do it really fast. Here's a cool way to do it with Desmos, though. Anytime you're trying to find factors of a number, you can put what you're trying to find factors of in the numerator and then divide it by x. And then just press the gear sign, edit list, and press table. And then you can just plug in values, because this table gives you values of x and y, right? So you can just plug in a bunch of integers for x, and then you'll see it. These are all the factors, like 160, 230. Those are all the factors of 60. It's a really fast way to make sure you didn't miss anything as well. And I just did the same thing for 34. And you notice the only factors are 134, 2, and 17. So now that we have all these factors, let's write them out in a list for p and r. Now that we have all the values of p and r, and we have the equation for b, we can just have Desmos run through all the possible combinations of p and r and see what's the highest value for b. We can do that really easily by doing 4. We can do 4 p equals p, and it's just telling Desmos to use the items from this list, right? And then r equals r, and you see it just runs through all of them. It gets 40. There was 48 numbers. That's 4 times 12. It runs through all the combinations, and then we can really just do max b, to get the maximum value of b, and it works. The answer is 2041. If for some reason the question was asking you for the minimum, you could do min b, same thing, and you get the minimum.